Hello everyone, my name is Barbara Nguse. Welcome to my presentation for Agriculture with GIS and Automation. I would like to start with the introduction of agriculture. Agriculture is the science of farming, including the cultivation of the soil for the growing of crops, fruits, and rearing animals to provide food and other animal products like milk, meat, wool, and so on. While agriculture technology refers to technology for the production of machines used on a farm to help with farming, agriculture machines and IT have been designed for practically every stage of the agriculture process, such as machines for tilling the soil, planting seeds, irrigating the land, cultivating crops, protecting them from pests and weeds, pruning, harvesting, threshing grain, livestock feeding, and sorting and packing the products. As we can see, from the 17th century to the 18th century, oxen and horses were used for power, crude wooden plows, sowing by hand, hoes and sickle, flail. There was more manpower. It was only manpower that was used in the production of food. In the 1800s, icebox refrigerators, US food canning industry was introduced. By 1840, 250 to 300 labor hours were needed to produce 5 acres of wheat. Manufacturing steel plows was introduced from wooden plows. Practical threshing machines were patented. By 1850, commercial farming, that is the factory made agricultural machinery, commercial fertilizer industry, and irrigation were all systems that were put in place to ease production and preserve food. By 1880, change from hand power to horses. That was the first agricultural revolution. Gang and talkie plows, steam tractors, spring tooth harrow, silos, and so on. 1900s, we see twine binders, hybridized corn, fast refrigerated freight car for transportation, cream separators, fast gasoline tractors, big open geared and enclosed geared tractors by 1920. 1940s, increased commercial fertilizers were used, frozen foods, spindle cotton picker, change from horses to rubber-tired tractors, which was a second agricultural revolution. As we can see, evolution continued. In 1980, 96% of cotton harvested mechanically. One farmer supplies about 47.7 persons, 3 to 4 labor hours for 3 acres of wheat, as compared to the 250 and 300 hours that were required for production of 5 acres of wheat. By 1889, more farmers began to use low input sustainable agriculture techniques. 1990 to 2000, one farmer could supply about 1,000 persons. IT and precision techniques increased, satellite technology to track and plan farming, FDA grants approval for whole food production, fast weed and insect-resistant biotech crops were available commercially. As you can see, from the 1840 to 2010, production by human labor has been dropping tremendously all the way down, and by 2010, technology is being used in agriculture as more manpower is increasing in the services sector. GIS and automation in agriculture. GIS is Geographic Information Systems. This is a system designed to capture, store, manipulate, analyze, manage, and present spatial or geographical data, while automation is the use of automatic equipment in a system of manufacturing or other production processes. GIS developed in US and Canada in mid-1960s. Agriculture uses GIS for advantages like mapping and projecting current and future fluctuations in precipitation, temperatures, crop output, which are meant to better manage the farms and deal with competition. More effective and efficient farming techniques that increase food production, crop and orchard monitoring, yield estimates, precision agriculture. Analyze soil data to determine the best crops to plant, where they should go, how to maintain soil nutrition levels to best benefit the plants. Many organizations like the USDA are now implementing GIS, including automation in agriculture, satellite-driven geopositioning systems. As we can see, there is a vine pruning robot in France called Wolier. It's being used for pruning vineyards, and less labor is used, human labor is used in production processes. For Japan, they are using what they call the vertical farming, where they use robo lettuce from the time lettuce is planted to the time it's harvested. They don't have to worry about the temperatures or the weather outside. They use LED lighting to help with the conditions that lettuce needs to grow. And then we can see the drones that are used for spraying pesticides and monitoring and watching over different fields of crops. These tractors are somewhere in I think it's I was going to say New York, but I meant to say England, where they are unmanned and they are projected to work all day 24/7 without, we may never see humans having to step on plantations or on any fields of crop to physically be engaged in agriculture. The robotic milking excuse me, and computer controlled feeding equipment, the genomic tools that are used to identify productive plants and animals, these are all used for automation in agriculture today. Trends in agriculture: technology adaptation from planting to harvesting. Thus, there is smart farming, the IoT sensors, and web-enabled tools in John Deere tractors. Vertical farming, that like we saw previously. Big data, that is converting data to actionable solutions that make the investment worthwhile and for it to work for farmers at local levels. Biologicals, like organisms that help to battle weeds and insects and diseases by major chemical companies. Regulations, which require water management and origin of commodities consumed to be accounted for. These could be time-consuming and costly for farmers to track paper trails. Demand, the increasing population versus food supply. If the world's population hits 9 billion people by 2015, the question is whether automation will be able to satisfy the demand. Challenges in agriculture: increasing demand for food. As we've talked about the increasing populations annually, we have to ask ourselves if automation will help, or humans should work together with automation to be able to satisfy the need for increased demands for food. Food wastage, there is wastage of food right from the time of production to processing it, to packaging of food, transportation of food, and sometimes most food is wasted by consumers. In America, consumers buy more food than they actually need and end up tossing it outside on a weekly basis. Demographic changes and loss of agricultural land due to a disconnected public. Less and less people are engaged in farming. Decades ago, families used to own farms, but now they are owned by big organizations or rich people, and the people who have land, when they are approached by those who are willing to buy it, they have big offers that they cannot refuse, and those who are willing to farm may never be able to afford land. So there is less and less land to farm on. Then unstable climate changes and resource depletion. Political issues like the business of food, where the government has to acknowledge certain GMO foods to be produced. Decreased varieties as well are a challenge in agriculture. Effects on agriculture technology. We have the positive and the negatives. The efficient management of funds and resources, irrigation systems, tractors, and mechanical innovations. All these make agriculture very easy. Higher crop productivity, decreased use of water, fertilizer, and pesticides, which in turn keep food prices down. Reduced impact on natural ecosystems, less runoff of chemicals into rivers and groundwater, increased worker safety. For the negative effects, we have GMO foods. I believe most of the food that we consume is genetically modified. I know that a usual cow doesn't look like that, but I don't know if you actually question the food that you eat before you eat it or you buy it. Pesticides, harmful effects to workers and consumers. Use of fertilizers can alter the biology of water bodies and through pollution. Less people are involved in farming. The job insecurities is also another negative effect that automation brings. Technologies that take labor out of the fields may undermine efforts to reduce poverty and enhance development. Ethical issues. Food safety. Through modern food production, transportation, processing, marketing chains that expose consumers to chemical additives, microbial pathogens, and other human health concerns, these need inspection and transparency to be revised. Environmental impacts. Chemical residues on food, pesticide exposure on workers, wasteful use of soil and water resources, and untargeted yet obvious impacts on the natural ecosystem and wildlife. Management of crops and livestock is when the environmental ethical issue comes in. Situations and rights of farm workers. This regards to protection of workers for their safety. And then distribution of benefits and burdens. That is the IT that widens or reduces the gap between the rich and the poor. Exploitation or control over genetic resources, GMOs, genetically modified animals and crops. Some say that it's playing God when you try to change nature and improve it in ways through GMOs. The questions to the group are, with the new satellite-driven tractors and robotic milking parlors, where will rural communities and cultures fit? And for countries still dependent on agricultural labor, what will people do to survive? Is the environment safe? Will would-be farmers be able to afford land? Is human health affected by the consumption of GMO foods? Do you think about the foods you consume before you eat or before you buy the food? Will farming be fully automated? Will farmers become obsolete? What challenges come with full automation? You don't have to answer all these questions, but just to make you think about agriculture and automation. Thank you very much for watching and listening. These are my references. You can ask me any questions. I'm sorry for any word that I may not have pronounced properly, but you can ask me anything. Thank you.